this morning's got a lot of lab. We got a relatively short, this is what it is, IP numbered and named access list. And this afternoon we'll do NAT, and then this is 8, and then we'll do 9. 9 relatively short. So IP numbered and named access list. 2 different ways to write them. What I want to do, as I have this nice blank here, actually let me try, because I think that I scrawl a little better on this, and I don't know why, than I do on the other one. But access control lists are just that. Let's see here. ACL filter. And depending on what kind of an address we have, or what kind of a list we have, we're going to filter different things. But access control lists, filter or control, let's say control access. 2 things. What are we going to control access to? To our network, to different portions of the network. If we had multiple locations, we had students and faculty and administrators, and always get in financial aid, because you really want to isolate those guys. We can control who has access to different parts of the network with an access control list. We're going to have 2 types. 2 types. We're going to have the standard, which are ICND1, and we're going to have extended, which are ICND2. So, yeah, we're going to do access control lists here, and then we'll do access control lists again next week. There's 2 ways to write them. 2 ways to write, which are going to be numbered and named. And we'll look at the difference between numbered and named. The real difference is the named. You can name it for kind of like what it does, and it's easier to edit. So it is easier to edit than the numbered are. The numbered are the original. The original has been around for a long time, and then, I don't know, maybe 10 years ago they came out with the named. Makes it a lot easier to do these things. It is an ordered list. An ordered list when we do it. And they're read from the top down. And what a system does, packet does, is goes from the top down. When it finds something that applies, it does it. In the old Nike, just do it. Applies, it just do it. Which means that when the packet, the IP packet, TCP segment, finds something that applies to it, it doesn't look any further down the list. So order is important, and that's why it's an ordered list. So ordered is important in these things when we do that. So we're going to go from the top down in order to make this thing work. Applies it, does it. At the bottom of the list, is an implied or an implicit, implicit, an implicit deny. What does that mean? That means that anything, if I don't permit, everything that I don't permit is denied. So deny is the policy on this thing. So it's a deny policy. We have to have at least 1 permit. We had a situation one time that, hey, we had an individual who was abusing their internet privilege. So, hey, easy, we'll assign a static IP address and just deny them access to the internet. Bingo. Deny them access to the internet. We did that. And then what happened was everybody got denied, because you go into the list and there's no permit. We have to have at least 1 permit, because this implicit deny at the bottom, since we said deny this IP, deny the IP, and then the next statement, since there was nothing else, was deny all, is the implicit. And you don't see this. What you'll find out in Cisco is the default configurations don't show up in the configuration files, and we'll see that on Friday when we look at port security. That if it's the default when we do the configuration and look at the config file, you don't see those things there. They're there. You don't see the deny all here, but it's there. What we should have had, and then after the internet was down for a couple minutes, nobody could get on it. We go in here and do a permit any here. So simply put the IP, the denied IP goes in here and hey, it's denied. It doesn't go any further. It looks at that statement, says, hey, this one applies to me. I'm going to do it. I'm not going to look at anything else. Everybody else came in and said, not me. And then it got here permit any and said, okay, yeah, I can go. They didn't get to the deny all. What the deny policy sort of does, I think, is it protects us, because we can either have a permit policy or a deny policy. If we have the permit policy, then everything except the things that we deny are going to go through. And I think that makes it easier to mess up when we do that. So we have those, the implicit deny. We have to have at least one permit statement. This is a two-step process. And process, and I told you I scroll. Two-step process. We write the list, and then we apply the list. And I want to do a demo to show that. And then we apply the list. And we apply the list at an interface. And we apply it as either in or out. In or out. And this is one that actually confused me for a lot of years until I finally sat down and said, okay, I got to figure this out. At the interface being right here, it's either going into the interface or going out of the interface. What confused me for years, and I know that the supposed to say I'm insane if I do stick figures, what they always said was based on or referenced to the man in the router. So the man in the router said, okay, so we're going to go into the interface here. No, it's not into the interface from inside the router. It's from the media, in or out, on the router itself. So we have the implicit deny, inbound or outbound. We need based on what we've seen here, hopefully, the more specific commands, the more specific at the top of the list, so that if we had the permit any at the top, and then the deny IP here, the denied station would never get there, because it would come in, see the permit any, hey, that's me, let me go on, and it would never get to that. So the order is important, the more specific things at the top, and the ones that are most used, or that you expect would be the most used are going to be at the top also, because then you don't have to read as deep into the access control list when we do those. And one that's not such a big deal anymore, but it's kind of something to know, we can have one per protocol, one list per protocol per one per protocol, per interface, per direction. That's a lot of pers there, I know, but what that says is we could have an IP going in and we could have an IP going out. And if we had IPX, we could have an IPX going in and an IPX going out. Again, this is not that significant anymore. These are things that a lot of these are holdovers from when we did have multiple domains. IPX was a NetWare protocol. Yeah, big deal to do these things. So let me see, I've got my little list here. We have an ordered list right from the top down. Applies, when it applies, it just does it and moves on. It's a two-step process. We write it and then we apply it, one per protocol, per interface, per direction. We had the implicit deny, and that really was to protect ourselves, and we have to have at least one permit statement for this thing to work, or we just wind up denying everything. We don't have a permit. So this is, going through looking at this, a much prettier picture than the one I scrawled out, but we have the packet coming in up here at the top, and it goes down the list. Does it apply? We come in the packet, the access control list at the interface. The access control list at the interface is looking at the header information. So the new firewalls do deep packet inspections, and they obviously cost more, but it's much more effective. What we're talking about in these firewalls are the header information, the TCP and the IP header information. And in the standard, the ones that we're going to use in ICND1, we're only talking about the source IP address. The source IP is the only thing that we use in the standard. When we get into the extended list next time, it's the source destination address as well as the port numbers, the services that we're using. So the packet comes in here. Statement 1 is that a match. If it's a yes and it's a permit, then it's forwarded. If it's not a permit, it goes down here to the bit bucket and gets dropped. Goes to the second statement. If it's a no, goes to the second statement. No, no, until we get to the end, and this is where our implicit deny would be down here if we get all of these no's. We can have explicit denies also, like the one I talked about, where we're going to deny one and permit everything else, but we still have to have at least one permit statement in order for that to work. Used to control the flow of traffic, the bullets here, identify traffic which can either be permitted or denied to the network, allow you to define a specific group of traffic and apply a condition based on a predetermined criteria applied by the Cisco IOS statements on a router interface, at the router interface, inbound or outbound. And the interface is where it goes to the media. Again, I told you, that really did have me confused for quite a while. So, and they used to have a default for these things. They don't have it anymore. You actually have to specify whether it's an inbound or an outbound. Validate each packet and determine whether the packet has to be blocked or allowed to pass. And again, if it doesn't find the header information doesn't find anything that applies, it's denied, because of the implicit deny that's on these things. The types, two types of IP access control lists are IP ACLs and extended standard and extended, the thing we talked about. The standard make filtering decisions based on the source IP address. You can apply the ACLs to deny access to a specific host or even an entire network. And we're going to use a thing called a wildcard mask. I know, different thing here. A wildcard mask. In a wildcard mask, the zeros say check it, and I'm going to give you a quick and easy way to do that. Check it, and the ones say I don't care. I don't care. So if we were, let's say that we are going to deny an entire IP subnet, 192.168.1.0. The wildcard mask would be 0.0.0.255. The 0 says check to see if it's 192. Check to see if it's 168. Check to see if it's 1. And if it is, I don't care about anything else. It's all of them. So we would use that. Quick and easy way to do that. If you know the subnet mask, we take 255.255.255.255 and subtract the subnet mask. 255.0, which will give us the 0.0.0.255. So the wildcard mask is used in access control lists. It's also going to be used in some of the routing protocols next time too. OSPF and EIGRP actually both use wildcard masks to specify what's going on with these things. So if we wanted the whole subnet, yeah, we would look, see if it started with 192.168.1, we just say no. And it wouldn't matter what the host portion of the address was. So the standard and the extended use wildcard masks. The other thing that is is where we apply these things in the path. The standard are closest to the destination. And first ship was in San Diego, and that's the way I remember this. SD, San Diego, source, standard closest to the destination. S, standard, D, destination, to do those things. Extended, so the extended are going to be closest to the source. And I don't know, you can maybe come up with one for that. I never could, for real. But once I know the one, I know the other one is going to be closest. The reason that the extended closest to the source, they're much more precise. The standard to the destination, if we had a situation that we had maybe a server here, and maybe a server here, and maybe the internet over here, and we had the network here, if we applied the deny the IP address at this point, we're going to deny all of these things, and maybe we only want to deny them this particular one. Or maybe we only want to permit this particular one. Maybe different things. So if we do a standard here, we wind up maybe doing a whole lot more than we really intended to do. And if we had the extended the source and destination IP address as well as the source and destination port, then we can be a whole lot more specific. Better if you do it inbound, because you don't have to worry about or take account of or use processing power of the router itself. And the standard and the standard list, and both of them can be either named or numbered. And again, and not in the beginning, but when I started doing this, which sometimes to me seems like the beginning, but we only had the numbered lists, and they are a pain. When we add something to an access control list, it gets added to the bottom of the list, which means that, hey, I've written this list, and I got 50 statements, and I forgot to put one in at statement 3. In the numbered list, I got to rewrite it because everything's added at the bottom. In the named list, the statements are numbered. 10, 20, and this is the way they go, 10, 20, 30, 40. Now in the simulator, it's going to show this for the number 2, and I don't think that's going to happen. So that if I had one here, 1, 2, and I need a third one in here, I could go in and as part of the statement put 25 and then whatever I was going to do with it. If you're using, so that kind of says, yeah, maybe I want to use named list. Besides the named list to tell you, you can name it what it does. It helps you keep track of things. If you are in a situation that you have to use the numbered list, use Notepad. You can copy and paste these things. So write the list, copy and paste it to Notepad or other actual text editor. You don't want to use WordPad or Word or those things because they put formatting information into it, and you don't want that. Notepad, and there are others, Notepad++, there are other, VI in Linux would do that. So you can copy and paste these things, and you can edit it, do the copy and paste for those. They both work the same way. They're written a little bit differently. And how these things work, let me go ahead, let me do my little demo here, and then we will come back and look at the rest of the slides. So what I have here is on this server, on my little fake server here, services here, I have a web server running, an HTTP and an HTTPS. And its address 192.168.2.2. And first of all, and what usually happens to me is, and I didn't check this, and if you want to see the ACLs, we can show, not ACL, access lists. Okay, there's not any here, and this is going to be handy too because it's going to tell us how many times it's going to be done. Let's do we'll do a numbered and a name so you can see the difference in a 1.3 and 1.2. I'm going to deny one of these guys, and then I don't have to, and then I'll do a permit. Actually, I'll do a permit one. I'll do a deny and then a permit and then a deny just to go through it. because we have the implicit deny. And just doing a demo, and what we're kind of looking at is some of the commands. So if I go into here and I do access list, and then you question mark 1 to 199 tells the system that it's a standard list. 100 to 199, and there are others which are going to be in the lecture, 1300 to 1399, in addition to, because when we did away with all of the other protocols for this, we came into a situation that, there's a whole lot more numbers available now, so they just use those. The IP being the major thing here. So access list 1. And one of the other disadvantages here is that you gotta type access list 1 for every statement, and when we get to the named list, it goes into an access control list configuration mode, and we can just go down. So first of all, let's deny, and then any host we can use, instead of using the wildcard mask in this case, we can use the word host, which is a lot easier to do. So let's deny 192.168.8.1.2. So after that, the only thing left, the CR, is the carriage return. And then we'll do access list 1 permit host 192.168.1.3. And after that, we would have our implicit deny. We could put a deny any, or we could put a permit any here. If we only want to deny that one host, then I could put a permit any after it, and we'll do that. We'll do that with the name. So what we now need to do after we've written it is to apply it, and I've got to figure out what port that is. Gig 00. So what we're now going to do is to apply the list, because we haven't done anything yet. Now we can see that here with our little web browser. That was 2.2, right? On 192.168.2.2, and we get our web page. And on this one, and I usually mess myself up when I do these, 192.168.2.2, and we can get there with it. So we've written the list, but the next thing we have to do is apply it, and since it's a standard list closest to the destination on the gig 00 outbound, going on to the media when we do that. So we're in config mode. Let's go to interface gig 0/0, and it's IP access group when we apply it. And the access group, either the word if it's a named list, or the access control list number. So we can now apply it. Incomplete command because I need to say out. So I now hopefully have this thing applied. And what we do, we denied 1.2 and we permitted 1.3. So let's see if it works. Yeah, let's see, 192.168.2.2. And we're waiting. And hopefully it's going to time out. Yep, request timed out. Can't get there. So let's see if 1.3 can get there, because that's the one we permitted. 192.168.2.2. Bingo, we're there. So another thing that you can do here to see if it's working or what it's doing, we can show access lists. I see all of my access list 1, and denied 12 matches. It kept trying to get there. And permit 5 matches. Got there. In this case, you can see how many times each statement in the access list was invoked. We can leave this list here, but we need to go back to gig 00 and do the no IP access group 1 out to take it off. And then I like to be sure I do a show run and look at gig 00, and we don't have anything applied to it. The way that we would do, we'll do terminal. Again, didn't type it. If you don't type the T for the terminal, it'll ask you how you want to do this thing. So in this case, the other one was just access list. This is IP access list, and then extended or standard, we have to specify this is going to be a standard, and then what we're going to name it. Let's see, the access list name, let's just call it demo, and I'm going to do all lowercase because they do become case specific. When I do this, you notice I'm now here, and it says configure the standard network access control list. So in this case, let's permit 192.168. Well, we'll do our deny first. Deny, well, let's go ahead and we'll do a permit just to show that the implicit deny. Let's permit 192.168.1.2. Let's do host 192.168.1.2. And that's all that we should need, because we're going to deny everything else. That's the only one that we're going to allow in there. Why would you want to do that? Maybe when we get into the extended, maybe for the administrator to be able to telnet to something. Those kinds of things. More specific. This is just the way we're going to start these things. So we're going to permit 192.168.1.2. Hey, now we have the implicit deny. And if I do the show, just to be sure that we have it, access list, and I have my standard IP access list named demo. So we'll go to config T interface gig 00, and I'll do IP. Let's see what I want to do. IP access group, and then the word is going to be demo, and we'll do it as an outbound. And then which one did we do? We permitted 1.2. So let's see if 1.2 can get there. 192.168.2.2, and he can. Now let's see if 1.3 is denied. See if our implicit deny works right. 192.168.2.2. And waiting, and we're going to hope that it says that I can't get there. Yep, request timed out, can't get there. And again, we can go back into the device and use the show access list. Hey, it let us get in. It doesn't show the implicit deny. It doesn't show how many things the default happens. That happens to the defaults. The default configurations don't show up in the list, in any of the configuration files. They're the defaults. And that's where we come into, we really kind of need to know what the defaults are for these things. So standard list filters by IPv4 packets by matching the source IP address. Each ACL of this type comprises of one entity, many lines of configuration commands. Yeah, we saw that. Many lines by many 2 lines, and then the many 1 line. ACLs enabled in one particular direction on the interface, inbound or outbound. Really old routers are going to have a default, and I think the default was, I'm not even going to say, I'll say one in or out. I don't remember. I think it probably was in. But there is no default, as you saw when I tried to do it early, that it says incomplete command. You have to specify whether it's an inbound or an outbound list. Each command in the ACL provides a matching logic that is applied by the router to filter packets. And it goes down the list until it finds one that applies, and then it applies that, and that's it. It doesn't look any further down the list. So the access list 2, permit, and this one is actually kind of incomplete here because permit what? It should be a permit host, or either that or it should have a wildcard mask after it. And then the named lists type of ACL filters IP packets using names instead of numbers. And you probably want to use, when you're doing this for real, probably want to use named list because you can name it on what it's doing. Deny students. Deny students financial aid, FinAid, or something like that to do these things. Named are easy to remember and edit. The reason is they are numbered and we can insert statements between them. I had a question one time, I guess it was on a switching test though, is what's the numbering? No, it was been on a router's test. What is the numbering system? They're 10, 20, 30. The default numbering system, 10, 20, 30 on down the line like those. Named ACLs use the Cisco ACL subcommand. We saw that. It was in configure the access list command. The command lines in the named ACL are similar to the standard, and then the named ACLs provide editing features for these things. My little summary slide for access control lists. More specific rules got to go at the top, and you know the more used ones also. They're applied from the top down. Once the header information finds something that applies, the header information carries out that statement, carries out that order, and doesn't look any further down the list. We have to have at least one permit statement because it's a deny policy with the implicit deny. And once it is written, we write the list, and then we have to apply it at the interface as either an inbound or an outbound. And we can have one list per protocol, per interface, per direction. So after that, let me stop